Howdy, calculates. Okay, so we're going to continue on this notion of the maximums and minimums. And so in order to be a maximum, I need to make sure that that y value, because it's really the y value that we're talking about, is greater than every other, so this new y value is greater than every other y value for every value in the domain. Hopefully that makes sense. So your one y value, if it's a maximum, is bigger than all the other y values. And then conversely, it'll be a minimum if this y value for C is less than, it could be equal to actually, but primarily less than, all the other y values for all x, again, in the interval. Kind of feels like Rudolph the Red-Nosed Reindeer, like this y value is smaller than all the other reindeer. Okay, that's just me. And the minimum and maximum are called extreme values or extrema. I was actually calling them that in your last video, so look, you're way ahead. So extreme values or extrema. We're just building your fancy calculus vocabulary. And absolute extrema occur at the highest point, which again you already knew. Can't spell though. Or the lowest point. So those are the absolute ones. And that is a P and an O and an I. And then the relative extrema occur anywhere there's peaks and valleys. Wow, look at how sophisticated our vocab is in calculus. And of course, if my function is continuous, remember I don't have to lift up my pencil, on some closed interval from a to b, so closed, that's why I'm using brackets, then it has to have both a minimum and a maximum. And I want you to think of this, that even if all I drew was this, if I make a closed interval, so let's say A being here and B being here, it does in fact have a minimum. The minimum just happens to occur at the endpoint, and it does in fact have a maximum. The maximum also just happens to occur at the endpoint. Of course, it's quite possible that I had some other fancy graph that was continuous, and the maximum and minimum don't occur at the endpoints clearly, because I would have a maximum up here, and I'd have a minimum down here in between A and B. But if it's continuous, there has to be at least one maximum and at least one minimum. Doesn't seem like rocket science, does it? Who came up with that theorem? I hope they didn't get named in a book. Doesn't look like, unless their name was extreme and last name value. Okay, so on these graphs, I want you, on each of them, this one's going to have closed endpoints. I want this one to have open endpoints. And then I want, I want this one to have open endpoints too. Okay, so it's continuous. It is closed on 1 to 5. This one's open on 1 to 5. And this one's also open on 1 to 5. And so when we look at absolutes, well, of course, on the very first graph, I have an absolute max. Whoops, absolute max. And I have an absolute min because it's filled in. On the second one, I have an absolute max. But I have no absolute min because where would you find it? I mean, it's close to this open dot, right? Closer, 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 closer. Stop touching me, stop touching me, stop touching me, stop touching me. The question is, what number are you going to use? 1.01, 1.001, what one? And then, oh, also on this last graph, I want an open circle at the top of the vertex. So this one has no absolute max or min because it's open at the highest point and open at the lowest point. Okay, see you in the next video, kids.